Today let's see continuity and differentiability, class 12, chapter 5, exercise 5.1, question number 4, 5. First let's start with question number 4. Prove that the function f of x is equal to x bar n is continuous at x is equal to n, where n is a positive integer. They have given function f of x is equal to x bar n, and we have to prove that the function is continuous at x is equal to n, where n is a positive integer. Okay, positive integer. So we have to remember two conditions for a function to be continuous. First condition is a function must be well defined at some point, that is x is equal to a. Okay, that is a function must be well defined. And next is the right hand limit should be equal to the left hand limit, that should be equal to the f of a. Okay, so let's start with the problem. First we have written the function is x bar n and x is equal to n. So here, to check the left hand limit and the right hand limit, we have to take limit x tending to x is now tending to n, x tending to n, function f of x. So function f of x is x bar n, limit x tending to n, x power n. So here, on substituting n in the place of x, we'll get n power n. Next is f of n value also we have to check. That is f of n is equal to n power n. Here, limit x tending to n, f of x is equal to f of n. That is, the right hand limit is equal to left hand limit is equal to right hand limit is equal to f of n. Therefore, function f of x is continuous at x is equal to n. Okay. This is the solution of fourth problem. Now let's see fifth problem. Is the function f defined by f of x is equal to x if x less than 1, 5 if x greater than 1. Continuous at x is equal to 0, at x is equal to 1, at x is equal to 2. So they are asking us whether the function is continuous at x is equal to 0, at x is equal to 1 and x is equal to 2. Okay, we have to check whether it's continuous or not. So here I'll tell the meaning of this. If x is less than or equal to 1, the function value remains the same. That is, f of x is the value of x. Whether we give 0.999, f of x will be also 0.999. Okay. If we take a value of -1, f of x will be also -1. And here is a constant function we can see whenever x is greater than 1. That is 1.2, the value remains the same. That is 5. 1.3, value remains the same. If it is 100 also, value remains the same. That is 5. Okay, now let's start with the problem. At x is equal to 0. First, let's write the function f of x is equal to x if x is less than 1, 5 if x greater than 1. So first we have to check at 0, right? So at x is equal to 0. So function here at x is equal to 0. What is the function f of x is? We can clearly see that x is less than 1 and since function is x. So okay, x. Next, the first is limit x tending to 0 f of x. So, limit x tending to 0, x is equal to 0. Next, f of 0 is f of x is equal to f of 0 is equal to 0. We can clearly see that the limit x tending to 0, function f of x is equal to f of 0. Therefore, f of x, function f of x is continuous at x is equal to 0. Okay, and next one, at 0 we have found that it is continuous. So let's see at 1. Okay, x is equal to 1. F of x, what is the function at 1? See, the function at 1 is x. Okay, x is less than or equal to 1. If it is 1 also, the function will be f of x is x only. Okay, first is f of 1 is 1. Okay, next, limit x tending to 1 from left hand side, because we have the x greater than and also less than. Okay, so f limit x tending to 1 from left hand side is, the function is f of x. Okay, so that is 1. Next is limit x tending to 1 from right hand side is 5. Function is 5 there. So we can clearly see that LHL is not equal to RHL. This is LHL, right hand limit. This is RHL, left hand limit. Both are not equal. We can clearly see the deviation at the point of x. Whenever x is equal to or less than, it is x. Whenever x is greater than 1, it is 5. Okay, at 1, the limit do not exist. Limit does not exist. The limit does not exist. So, we can say function is discontinuous. The function is discontinuous at x is equal to 1. And the next one is at x is equal to 2. At x is equal to 2. The first one is the function at x is equal to 2 is, see, if x is greater than 1, the function is 5. So, function is here 5, constant function. F of, okay, so function f of x is equal to 5. F of 2 is equal to also 5. Okay, next is limit x tending to 2, function is 5, which is 5. The limit of any constant value is the value itself. Okay, so limit x tending to 2 of 5 is equal to f of 2. Therefore, f of x is continuous at x is equal to 2. We can see at 0 it is continuous, at 2 it is continuous, only at point 1 it is discontinuous. Okay.